Hey guys, today we're going to now do our introduction into limits lesson here. Now, limits, what does it mean? Well, basically, you can think of limits as where a function is going to when x is going to a certain value, depending upon what value we're talking about. It could be different things, different situations. So, the formal definition, and you might want to jot this down in your notes, is a limit is the value a function f of x approaches as x approaches a value. So as x goes somewhere, where does f of x go? And if you remember, f of x is just a fancy way of saying y. So where's y going as x goes to a certain place? Now, all mathematics is really about its notation, the plus sign being the cross looking thing, and then the subtraction symbol, everything symbols, and the symbols here that we use to express this, or the notation, look something along the lines like this. First of all, I'm going to apologize. This is this big gap here. Normally not written like that. A little bit closer together here. So if I was writing this down on the board, I would say limit as x approaches a of a function equals a certain value. And we like to use capital L to represent that value here in the very beginning. So yeah, that's the symbols. But what are the words? The limit as x approaches a of a function f of x equals L. That's what it's saying. This is what the x value is going to. This is the function. This is what the y value is going to. So that's f, that's the function, and that's the y value. Just so you understand the notation. Okay, so all right, let's just draw something here for you. Let's say we have a function. All right, let's make our little function right here. Whoa, there it is, going something like that, and it's a very nice function. And I'm going to call that function f. And let's say that this x value over here, I'm going to make up a number here. Let's say the number is 5. And let's see, so then this would be the point on that graph when x equals 5. Now the y value that goes along with that would be, I don't know, again, just making up a value. Let's say the y value is 3. Okay, so you can see there's the y value, there's the x value. So then the notation that talks about this story would be the limit as x approaches 5 of the function f of x equals 3. That's it. Now, when we talk about a limit, though, we have to talk about how it gets there, how it gets to 5. In other words, you can come from two different directions. You can come from the left, that's going this way, and you can come from the right, that's this way. So as you approach from the left and you approach from the right, in this particular case, you're getting to the same point, which is super important for us, and we'll tie that all in together some another time. But let's talk about that left and right real quick. Now, if I was talking about that left and right, if I was talking about the left, the notation I would use would be the limit as x approaches 5 with this little minus sign. That's what the left notation for the left, I should say, is. So as I approach 5 from the left of f of x, it equals 3. Let me give myself some more space here. Now, as I was talking about from the right, because you can come from the other side, if I'm talking about the right, I need to say, instead of using a little minus sign where it looks like where an exponent would go, I'll use a plus sign right there. And as I approach from the right, whoop, I'm approaching the same value, 3. Now, these guys independently are what we call one-sided limits. So in other words, we're approaching from one side, the left or the right. Now, this guy up here in the beginning, whoops, thing jumped. This is called a two-sided limit. So as you approach from the left and you approach from the right, you're approaching from both sides. Two-sided limit. A little terminology for you. So a limit exists if, as x approaches from the left and the right, the y values are the same, which is what happened in the last little example. As I approached 5 from the left and 5 from the right, I approached the same y value. So the limit exists. So if you've ever watched the Mean Girls movie, sometimes there's like a line in there that says the limit does not exist. I never watched the movie. I have no idea. I don't know how accurate it is. Most of the time when I see mathematics and higher level mathematics done in some sort of Hollywood movie, it's bogus. But anyway, now I sound like Neil deGrasse Tyson talking about physics in a sci-fi movie. A limit exists if x approaches the left and the right from the same y values. Okay, all right. Give me some notation there, Turn Chalk. All right, there you go. There, guys. So this, as we said before, is the left because it has that minus sign. This is from the right because it has that plus sign. And this is saying as I'm approaching both sides. So if I approach from the left and I approach from the right and I get to the same value, then we can say the limit exists and it equals that value. All right. Oh, nothing else. Let's look at an example. Here's a little picture. All right. Now, looking at this picture here, what I'm not showing you is where 4 is. There's 4 right there. You can probably count it and figure it out. As I approach 4 from the left, what's my y value? So this is coming from the left. You're getting closer to 4. By the way, you're getting infinitely closer. You're never really getting there. It's like you're going to 3.9999999. Whether you get there or not doesn't matter. It just matters to what you're getting close to as the x value is getting closer to 4. So the y value you're getting close to looks like it lines up with the number 2. Whoop. That's how you do that. Now, the part B of this is, okay, as you approach from the right, here's the right. As you approach from the right, what are you getting closer to? Oh, it looks like you're getting closer to the number 2 from the right. Now, since both the left and the right are the same number, then the answer is 2. The limit exists, and it equals that same number. Now, what the heck is this little part over here? G of 4. There's no limit here. It's just asking me what is that value. This is no different than what you did in Algebra 1. You just look here, G of 4, it equals 2. The implications of that, where all these numbers are the same, we'll be talking about that in like a week or so. Don't worry about it, but I'm just trying to lay the groundwork here. All right, last little thing I want to look at here is, all right, I got the same picture here, but now I'm looking at a different x value. As I approach 2 from the left, getting closer to 2, getting really closer to 2, it looks like I'm getting close to 1. Whoop. As I approach 2 from the right, here's the right-hand side of it, getting closer over here. All right, I'm getting closer. Again, I don't need to get there, but what am I getting close to? It looks like I'm getting close to the value of 3. Okay, now since the left and the right are 2 different numbers, then this does not exist. So we can actually write D and E, which stands for does not exist. So if you don't approach the same number from the left and the right, you write D and E. All right, G of 2. Moving on. Now, G of 2 is like, okay, what's the value when x actually equals 2? Now, which dot is going to be the value? The filled in dot. The filled in value is 1. All right. I threw 2 last questions down here because we're going to spend a lot of time with infinities and interpreting different kinds of infinities. I know that sounds crazy, but just hang on for now. As you approach negative infinity, what's the function getting close to? So as I approach negative infinity, I'm never going to get there, but it's heading this way. What's the y value it's getting close to? Well, that's going to be going down forever based upon what that arrow is telling me. If that guy's going down there forever, we could say that that function, the y value, is going to go to negative infinity because it's going down forever. In a similar way, as we approach positive infinity, so here we are, we're going positive infinity, we're going to go all the way forever. Well, what's the y value? See the way the arrow is pointing up? He's going up, which means that he'll be going up Sandlot style forever. All right, I did my best to attach some sample problems. Give them a go. Bye for now.